We are the students of the course MCL 321, and my name is Amatya Bharadwaj, and my partner's name is Sandeep Ganesh. And the topic of our project is Synchromesh Transmission. Initially, in the late 1800s, a conventional three-speed sliding gearbox was in use. Due to extreme noise generated in it, it was later used less and led to adapting to the constant mesh gearbox. Then, as the time passed and industry advanced, a synchronizer device was added to the constant mesh, which made it Synchromesh Transmission in the year 1929. Now, we will look at a video demonstration of the transmission gearbox shot by both of us in the IIT Delhi lab.
Hello, we are the students of the course MCL 321 Automotive Systems, and we are here to shoot the video presentation of our project that is the Synchromesh gear transmission. And my name is Amatya Bharadwaj.
And I'm Sandeep Ganesh, and we'll be showing all the elements and we'll showing the working principle of the Synchromesh gearbox.
So hello, this is the gearbox which we'll be studying today. So this is a starter motor, and we will not be using it for the demonstration today. We will only be giving the input through the flywheel. So this is the input flywheel here, and this is the output flywheel, and this is the input shaft, and this is the output shaft, whereas the inner thing which you can say at the bottom, it is the lay shaft. The input shaft is always connected with the lay shaft, and this thing which you can see, it is for the reverse gear, and the gear is currently in neutral position. As you can see, no movement. Yes.
So this is right now in neutral gear, and we'll shift it to first gear right now. So we can see the motion of the input flywheel and the output flywheel, both are in the same direction. There are 4 gears right now, so we are just engaging one of them. So the idler shaft here the gear and idler shaft has been engaged to the gear and output shaft, and now as I rotate the flywheel in clockwise direction, we can see the output is coming in anti-clockwise direction, which shows that the reverse gear has been engaged.
So this is the schematic representation of the sliding mesh gearbox. As shown in the figure, we can see there are 3 shafts and 6 gears. The 3 shafts namely are input shaft, lay shaft, and the output shaft. So the output shaft is splined, which means that the gears can move left or right on it. The lay shaft, whereas, is solid. That means the gears are fixed with respect to the shaft. We can see the black arrows. This indicate the power transmission. So we get the input power from the starter motor, and this transfers to the gear in the input shaft, which then transmits the power to the gear in the lay shaft, as we can see in the flow of the arrow. And then finally, whenever we choose a particular type of gear, in this case, gear 1 and 2 are engaged. So the power will get transmitted from gear 2 in the lay shaft to gear 1 in the output shaft, and then it will go to the engine. Next slide, please. So in general, we have 1 to 4 gears with an extra top gear and a reverse gear. So to engage gear 1 to 4, we can use different orientation of the gears of output shaft and connect it with the lay shaft. And if we want to engage the top gear, we can directly connect the output shaft to the input shaft. And for a reverse gear, we use the idler shaft. The gears which are used in the sliding mesh gearbox are called spur gears. Next slide. So the basic disadvantage of using spur gears is that these are very noisy. This is due to the fact that the gears which are rotating in output shaft and the lay shaft are rotating at different speeds. So whenever we are trying to engage both of these gears, we will hear the spur gears rotating at different speeds will provide friction, and this will cause a lot of noise. Also, this will lead to a sudden load or jerk due to differential speeds of clutch and gear, which will cause a load and can also damage the gearbox.
Now, we will look at the constant mesh gearbox. This is the constant mesh gearbox, and as the name suggests, the gears are in constant position. The gears in the output shaft are connected to the lay shaft but are not engaged. To engage the gears, the dog clutch and fork are used. Whenever we want to engage the gears, fork will attach itself to the dog clutch and will move left or right to get engaged with the gear on the output shaft. When the dog clutch gets attached to the gear in the output shaft, the power gets transmitted from gear inlay shaft to its attached gear in the output shaft. The disadvantage in sliding gearbox was that it caused huge noise due to the spur gears, and hence helical gears are used here in the constant mesh gearbox. The limitations of constant mesh gearbox. In the dog clutch present here, the teeth are vulnerable and are prone to damage. When engaging the gears, the difference in speed between the dog clutch and gears make it difficult for engagement and hence leads to sudden jerk which can damage the gearbox.
Synchromesh gearbox. So synchromesh gearbox is very similar to constant mesh gearbox in that the mechanism and the schematic construction of the gearbox is very much similar, but only difference is that we have an extra synchromesh device. So a synchromesh device consists of two parts. First is the friction cone gear and second is the synchronizer, which also has a ring above it. So the main reason for making synchromesh gearbox is to avoid the necessity of double declutching, and also it solves the problem of reducing jerk generated due to different speeds of clutch and gear during engagement. Next slide, please. So this is a schematic representation of synchromesh gearbox which we have gotten from the internet. We can see very similar construction as the constant mesh gearbox, like we have the input shaft, we have the lay shaft and the output shaft. And in the gears, as we can notice, these are not the normal rectangular gears, helical gears, but we can see a conical protrusions as well. So we can see the difference in the next slide. Yes. So as we can see, the constant mesh has a rectangular slab from the side view, whereas the synchromesh, we can see a protrusion or a cone, and this is called the friction cone. This friction cone is introduced forming a tapered surface area, and it is sometimes also referred to as the external cone. Next slide, please. So like the dog clutch in the constant mesh gearbox doesn't have any protrusion inside or outwards. In the synchromesh gearbox, we have an extra clutch which is known as a synchronizer, and we can see in the diagram that it has a tapered surface towards the inside of it. So this is also called as the inner cone, and this slide shows the working mechanism. The grooves in the clutch attaches to the fork and moves the gear left and right, similar to what happens in the constant mesh gearbox. And what happens then is the internal cone of clutch gets connected with the external cone of gear. This engagement is known as a friction engagement. And next what happens is, once the speeds are matched by the friction contact, the two teeth of the synchronizer and gear get aligned. The ring then moves forward and transmits the power to the output shaft, and this mechanism is called the positive engagement. So this is the basic difference between synchromesh gearbox and constant mesh gearbox, wherein in constant mesh gearbox, also in sliding mesh gearbox, there is only one type of engagement, which is the positive engagement, whereas in synchromesh, we first try to match the speed so that there is less load and jerk provided to the gearbox, and then there is positive engagement.
Now, we will look at the advantages and disadvantages of the synchromesh type of transmission. Advantages. The synchromesh type of transmission has the big advantage of allowing smooth type and quick shifting of gears without danger of damaging the gears and without necessity for double clutching. The synchromesh transmission is considered as the most advanced and hence has been widely adopted in the most cars. This type of transmission eliminates clashing of gears and makes shifting easier. Here, engagement is done without noise or damage to the dogs. Disadvantages. This type of transmission is expensive due to high manufacturing costs and comprising of more number of parts. This is not capable enough to handle high loads. Upon improper handling, this is easily prone to damage and hence requires heavy maintenance. It could be affected by quick clutch disengagement on shifting. So this is the reference which we have used for the image present in our slides. Thank you.